Just for completeness sake, let's quickly run through the Earth's history again with some major steps along the way. So let's read this again. We have said before in the other section, which you may or may not have gone through, may or may not want to go through, but this section should be complete on its own. So if you want to just stick to this one, it's okay. But other sections have things on how energy is balanced on Earth and why it has to move from one place to another, how it moves from one place to another, and so on and so forth. So we mentioned already snowballs and volcanoes, which we will read again. Snowball is where the entire Earth almost completely got covered with snow and ice, and why it happened, and how volcanoes then unfroze that planet and got us out of the so-called Snowball Earth. And maybe there were 3 such episodes in the Earth's history, that the history of Earth has had a lot of ups and downs. And we'll see where the first rains came from and how the Earth changed into a snowball from top to bottom, and what sort of scary critters crept and crawled among the first plants, why the dinosaurs died out. You already know, because you've heard about this a lot and read about this a lot. And we'll see how a few giant farts from the sea caused a heat wave, which means some greenhouse gas must have come out. Are you allowed to use a word like fart? Well, I don't know how old you are, and I'm talking as if you're a little kid. Maybe you're old enough, but nonetheless, we will see what those farts are. And in fact, one of those big farts may have caused this Paleocene-Eocene thermal maximum that we talked about, where the Arctic got covered by palm trees and so on. So keeping that in mind, in short, we will learn about the early history of the climate, and we'll start with a very quick run through 4.6 billion years of Earth's history. The solar system formed, Earth got formed, all the other planets got formed. We don't know all the exact details, but we know quite a bit. So birth of the Earth happened somewhere around 4.6 billion years ago, or 4,500 million years ago. Remember, 1,000 million is a billion, and we had 3.5 billion or 35 million years, 3,500 million years ago. Potentially photosynthesis I already started, so you had some sunlight mixing with these bacteria, the photosynthesizing little algae that started to capture the CO2, use the sunlight, and combine with other nutrients and produce carbohydrates and sugar and release oxygens. Okay, and it would have all happened within the ocean or somewhere in the mud, we don't know exactly. And jump forward from there to 700 million years ago, so less than a billion years ago, where we had the first Snowball Earth episode. Can we always say why it happened? Not always, but for some reason or the other, you would have started freezing the poles, let's say. And then what happens? You haven't learned it here, but the snow and the ice reflect a lot of the sunlight. They are bright white, which means the energy coming from the sun is going back in large quantities to space, so the Earth gets very little energy, which means more cooling happens and more freezing happens, which means there is more surface with bright white surface, which means more energy is going back and more freezing happens, and so on and so forth. And we called it the vicious circle, or the positive feedback in the scientific literature. We looked at it in the last section in chapter 10, and soon you had the entire planet get covered by snow and ice, and we called it the Snowball Earth episode. And jump forward to 450 million years ago, continents were still moving around, and sea level was going up and down, and mountains were still building, and so on and so forth. But land plants began to start growing, and we have things like the trilobite and so on appearing here as well. So you had plants on land which started to do photosynthesis, and What does that mean? They began to take up CO2 and started putting it into carbon and growing the trunk and growing the branches, and soon you had so many plants growing that they took down a lot of the CO2 and produced all this organic matter or the tree trunks and so on, which then got buried underground because continents were still moving, and then snow and ice started to fall because you took down a lot of the CO2 by growing a lot of plants, and then you had all that organic matter get compressed and converted into peat and then coal. So you had 300 million years ago, lots of the coal, almost all of the coal that we now keep digging got converted from organic matter into coal around 300 million years ago. What came next? If we go to 66 million, so we jump from 300 million straight to the dinosaur extinction when the meteorite crashed, and we know dinosaurs died out. We have chemical ways and geological ways of figuring out that it was a big meteorite that crashed, and it crashed in the Yucatan Peninsula in the Gulf of Mexico, in the Western Hemisphere, and we know that the dinosaurs got massively affected and wiped out the entire species, and we had mammals become more and more abundant across the planet. And we talked about the palm trees at the North Pole 55 million years ago with the Paleocene Eocene thermal maximum. You jump forward to 45 million years ago. India as a continent was way south of the equator, crunched together with Australia and Africa and Madagascar. It broke off and started drifting northward across the equator into the Asian landmass which was there, and it started pushing under the Asian landmass and pushed the land in front of it to grow into a mountain, the Himalaya. And Himalaya still grows because India continues to move north and push the land up. So India moves forward at about maybe 3 centimeters per year, and the Himalaya grows maybe by 1 centimeter per year or so. Then came the ancestors that started to walk on 2 legs as opposed to the chimpanzees and gorillas, which are related to us genetically. They all mostly walk on all 4s. Some climate change, some vegetation change in Africa, Eastern Africa happened, and for some reason of how vegetation affected us, our ancestor like Lucy started to walk upright on 2 legs instead of on all 4s like chimpanzees and gorillas do. And we know that that is probably one of our closest relative that is found so far back, but this timeline will keep changing because scientists go on finding new fossils that say exactly when we evolved and what did it have to do with climate change. You jump forward to 2.5 million years ago, ice ages began, so ice began to grow and glaciers got built in Antarctica and Greenland and some other mountains like the Himalaya, and then they melted away after 100,000 years ago. New glacier grew because, as we learned in the previous section and other sections, the Earth's orbit is not fixed. It's in an elliptical orbit around the Sun. Sometimes the ellipse gets more ellipsoidal and sometimes becomes more circular, and the tilt that is now at 23.5 degrees sometimes becomes less, and sometimes it becomes a little more, and then it also wobbles like a top around its axis as it rotates and so on. So the energy coming in changes and redistributes from hemisphere to hemisphere. You start growing ice and you keep growing it. You start melting ice and you continue to melt it. And all this happened naturally, not because we were there to change the greenhouse gas concentrations. It just happened because of the way Earth's orbit around the Sun changes, and sometimes also because Earth's energy itself changes because there are some knots on the Sun's surface called the sunspots, as we will see a little bit later on. Okay, move forward now to 450,000 years ago. You have saber-toothed tigers, and if you go to 45,000 years ago. We have some rock drawings, which means our ancestors, maybe Neanderthals and other ancestors who may be other lineages. Remember, we are Homo sapiens. There were other Homo lineages if we go back, but by 45,000 years, maybe only Neanderthals were left, and maybe Homo sapiens were left. Maybe there were some Homo devonians and Floresiensis and so on and so forth. If you don't know what that means, don't worry about it, okay? But generally, we had some ancestors who knew how to draw and how to try to communicate. They were maybe sitting during a cold winter in a cave, and they were painting things to pass time or to leave a message behind and so on. So you jump forward to 10,000 years ago. That's very recent compared to this 4.6 billion years of history, and that's when the last ice age ended. Okay? And we were hunter-gatherers. We were going around in small groups and hunting and gathering roots and fruits and eating them and not settling down in one place. But we learned to domesticate wild grasses like wheat and rice, and then came agriculture and potatoes and peppers and so on and so forth. And we began to get more and more in numbers. Population grew. We began to take out more forests to grow more food. We began to build cities and militaries and hierarchies of governments, like a king and a ministers and a accountant and so on and so forth. And by 4500, the Egyptian region had the pyramids, which are now one of the 7 wonders of the world. So we jump forward in 500 years ago, we had Mona Lisa, who now remains in the Louvre in Paris, who is so famous. And just 300 years ago, we had a little bit of freezing called the Little Ice Age. So we'll see how this may have come about, what volcanoes do to the energy that is in the system or going out of the system. There is energy from the sun coming in and thermal energy going out. What does it mean? We eat all this food and we are emitting thermal energy from the body. Remember, when you're cold, you have a blanket because you trap the thermal energy from your body and make yourself warm, or your mom gives you a hug and you feel the warm hug because the body is emitting thermal energy. So we are converting sun's energy into thermal energy. That thermal energy has to go out to space, otherwise we'll get warmer and warmer and warmer and warmer. And why does the thermal energy get trapped? Because we have things called greenhouse gases which trap this energy, which is what we started increasing 250 years ago or so, when we started inventing things in large numbers and building things in large numbers, building factories and making things that everybody can use, but everything took energy and we kept burning coal and then gas and petrol and so on. Okay, just go back 45 years ago when your mom and dad were still very young and they were talking, like babies, like you did, dada and a mama and so on. And now you're old enough listening to me and asking questions of your parents and saying, where did we come from? What have we done? What have you done to my future with all these greenhouse gas emissions and all the warming? Well, you can also ask them what they want to do about it, what they think about it, and what you can do about it, and so on and so forth. Okay? So we'll come back and talk about the old Earth in a bit more detailed way, and you will learn more about what we have been doing and what has happened naturally before we came along with Lucy maybe a few million years ago and so on. Okay, see you in the next podcast, children. I hope this is fun.